A few people mentioned having difficulties with our total equations, total ionic equations, net ionic equations, and working those on our homework. So this is going to be a little bit of a tape so that you can actually see me work through a couple of these examples. The first one's going to be an easy one where there's only a 1-to-1 ratio for everything, so we're going to focus in on the methodology and not worry about those details of having to balance things out or anything. But then a second one we'll do is actually going to be one where we have to watch for balancing those equations and looking at the ratio of what thing is to what thing. So let's go ahead and do this one. The problem is that we've got silver nitrate, and that's a soluble solution, so it's got the AQ there, and it's being added to a solution of potassium bromide. It's soluble as well. It's got the AQ, and those AQs tell us that it's soluble. So the first thing we need to do is figure out what products we're going to have here. We know that these two compounds, when they get together, they are soluble. We know when these two get together, it is soluble. But when we mix them, now all of a sudden we're going to have Ag pluses floating around. We're going to have NO3 minuses floating around. We're going to have some K pluses floating around, and we're going to have Brs floating around. And they're going to be all mixed up. Now if this positive goes with that negative, we know it's already soluble. No precipitate's going to happen. But if this guy gets with that new guy, now that's the question. Are these guys going to precipitate out? And likewise, then, are these guys going to precipitate out? So our true question is, what's going to happen when they switch partners? Okay, so that's exactly what we're going to do. We're basically just going to have them switch partners. So the Ag goes with the Br, and the K is going to go with the NO3. Now when we do this, we want to make sure that we are writing the correct chemical formula for silver bromide. So we have to check, this is a +1, that's a -1, so it is a 1-to-1 ratio. This is a +1, that's a -1, so it is a 1-to-1 ratio. Like I said, this beginning one we're not going to worry about those things too much because they're all 1-to-1. So once we've flipped partners, now we have to see, well, is this product going to be soluble or insoluble? Okay, and for those we have to go to our solubility rules. And in OWL we had a list of solubility rules. I also have one slide that has a list of solubility rules. So do make sure you memorize those because you're going to need them in order to do this type of analysis. So we're going to look at silver bromide, and we said that our rule is that most of the halides, the chlorides, the bromides, the iodides, most of those are soluble except silver. So silver is that exception. And oftentimes you'll find out that the problems that you're given have the exceptions in there because that's what causes it to come down. So this one is insoluble. If it's insoluble, it's going to form a solid. Okay? Now we'll double check this guy over here, potassium. The group 1A, in particular potassium, are almost always soluble, and the nitrates are almost always soluble. So both of those give us reason to think that that is soluble, AQ. Now this is the total equation. At this stage, after we've switched partners, we want to make sure this is balanced, because this is the easiest place to balance it. Okay, we've got one of those, one of those, one of the nitrates, one of the nitrates, one of the Ks, one of the Ks, one of the Brs, one of the Brs. So it is balanced. Like I said, this is going to be an easy one. So after we've made sure that that is balanced, we can say, okay, this is a balanced total equation. Now we want to do the total ionic equation. And to do the total ionic equation, what you're basically going to do is take any of the AQs and you're going to break it down into their ions. Okay? As we are breaking it down into the ions, don't forget to include the charge. Okay? And get the number of them correct. Now, remember, when they're in their ionic compound form up here, there are no charges there. If you put a charge in there, that's going to be counted wrong. But in the total ionic equation, we want to make sure that everything has a charge unless it's the solid. Okay. So we're going to break this down. This is soluble. Anything that has AQ is going to go to its ions. So this is going to be Ag, AQ. The ion for Ag is a plus. Then we're going to add the NO3, which is an AQ. The ion is a minus. Now we have to do the ions for this guy. The K is a plus. The Br is a minus. And of course, we've got to include our AQs in there. Don't forget these subscripts. They tell us the state of matter. They keep us in mind of whether it's soluble or whether it's insoluble. We're going to draw our little arrow. The solid is the one thing we keep together because it stays as a solid. They don't separate. So we're going to write that as our solid. And then this is another AQ. So the AQs get broken down to the ions. So this is the total ionic equation. All right? If it's balanced up here and you do the transformation for the numbers right, it'll be balanced down here. Now, to get the net ionic equation, we have to find the spectator ions. Remember, those are the guys that are just watching. They're not actually participating in the chemistry. They're going to be the same on this side of the equation as they are on this side of the equation. So identify the spectator ions. Well, we've got nitrate over here. We've got nitrate over there. That's a spectator ion. We've got potassium over here. We've got potassium over there. That's a spectator ion. These other guys, we've got them in ion form over here, but solid over there. So they're different. So now we want to write the the net ionic equation. And the net ionic equation is just going to be bringing down those guys that are not spectators. They are the ones that are actually doing the chemistry. And don't forget your AQs over here. So Br minus. And we're going to have it go to a solid. This is the net ionic equation. Okay. So, like I said, this was 1-to-1 ratio for everything in here because we just wanted to go focus in on the methodology. We flipped partners here, made sure we had the correct chemical formulas, figured out which one's soluble and which one's not. Then we balanced it. Anything that was AQ up here, we broke down into their ions to get the total ionic equation. We identified the spectator ions, and then anything left is the net ionic equation. Let's try another one where we have a little more stuff going on here. So that was fairly straightforward. Let's do this one. We've got sodium carbonate. We're told that it's soluble. We can figure out it's soluble because it's a sodium there. And we're going to mix it with aluminum nitrate. And those are the chemical formulas for each one of those. Okay. And we're asked for total equation, total ionic equation, and the net ionic equation. So let's go ahead and go through each one of these. Again, the first step is to flip the partners. So the sodium now all of a sudden gets the nitrate, the negative guy over here. Remember, sodium is a +1, nitrate is a -1, so they have equal charges. It's a 1-to-1 ratio. Okay. Let's try the next one. The next one, we take the positive guy over here, aluminum, and we put it with the negative guy over there, the carbonate. Now we've got to remember what these ions actually are. Aluminum is a +3. Carbonate is a -2. So when we go ahead and look at this ionic compound, this comes down there, we'll do the shortcut, this one goes down here. The ionic compound is aluminum with a subscript of a 2, and the carbonate with a subscript of a 3. That is what has to get put up there, because we need the correct chemical formula for aluminum carbonate. So we need our 2 as a subscript here, and the whole thing gets a 3 over there. Now, for that, all we did was switch partners and make sure we had the correct chemical formula for each one of those products. The next step is to determine which one is soluble and which one's not. That was our starting one, that was 18. So let's look at these. Sodium, all sodiums are soluble, all nitrates are soluble. So that one's going to be an AQ. Calcium carbonate, the carbonates are not soluble. So that's where our solid is going to be. Okay. Now we're not quite to the total equation because we have to balance that guy. Okay, so we've got, let's see, we've got 1 aluminum over here, we've got 2 over there. That means we need a coefficient of 2. 2 aluminums, 2 aluminums. Okay, now we have 6 nitrates, which means, move that over a little bit, we need 6 of the nitrates over here. Sodium, we have 6 sodiums. It means we need 6 over there. That means we're going to need a 3 in front of this guy. And the only thing we haven't balanced yet are the carbonates, 3 carbonates, and we have 3 carbonates over here, so it works out. Once this is balanced, now we can call that the total equation. Okay. We've already identified which things are AQs. To get the total ionic equation, we're just going to break those AQs down into their ions. Be careful that you're keeping track of how many of each thing there are. Okay? So here we've got 3 sets of 2 sodiums. 3 sets of 2, that's 6. So we have 6, and the ion is sodium plus, right? Sodium is always sodium plus. The ion here is carbonate. So the carbonate is CO3 minus 2. We have 3 carbonates. So 3 there. Okay, and that's an AQ. We have 2 aluminums, and aluminum is always a plus 3. Of course, an AQ. And we have 2 sets of 3 nitrates. So that makes 6 nitrates. And nitrate's always a minus. AQ. Alright. Now, we'll do the same thing to this side. Remember, we're only doing the AQs. This is an AQ, so we have 6 of the sodiums. AQ. And we have 6 of the nitrates, which is an AQ. Don't forget the charges. The solid comes down as a solid. And you're done. That's the total ionic equation. Remember, if you balance it there and you get the numbers right as you're bringing them down, this is going to be balanced. Now let's identify our spectator ions. We have sodium over here. It looks like a sodium ion over there. We've got nitrate over here. We've got a nitrate over there. Those are the spectator ions. We're going to just bring down everything that's not a spectator ion. The convention is that we put the positive guy first, so I'm going to reorder these. But it's exactly the same thing. 2 aluminums that are plus 3, and 3 CO3s, which are minus 2. And it goes to the solid aluminum 2, CO3, subscript 3, that's a solid. Now this is the net ionic equation. So your homework goes through little steps of this. I expect you to be able to do this whole thing. Okay? If I'm giving you 2 of these things, I want you to be able to do this whole thing. Your homework takes it in little chunks. Okay? So it asks little bits of these questions at a time. For example, it'll give you 2 solutions and ask you, well, what's the solid product? Keep in mind, not all of the boxes are getting filled, so be careful with that.